Hello, everyone. My name is Pooja Wag, the Director of Results Measurement and lead of the health community at MIT Solve. Here at Solve, we're building a marketplace for social impact innovation. Through our annual global challenges, we find tech entrepreneurs from around the world and broker partnerships with leading organizations to scale their work and create lasting transformational change. We believe that talent and ingenuity exist everywhere, but too often the most promising innovators lack the support they need to reach their fullest potential. I'm therefore thrilled to welcome you to this AI and machine learning short course created in partnership with the Patrick J. McGovern Foundation. From this course, we hope that social impact entrepreneurs like you will learn how to leverage AI, including machine learning and other data science methods, to broaden and deepen your social impact. Over the next 60 minutes, you'll hear from AI experts at MIT and beyond, including from two of our Solver teams. They'll discuss the opportunities and limitations of using AI for social good, how you can identify where to use this technology in your work, and considerations you should keep in mind as you build and implement your own AI strategy. To kick things off, I'd like to introduce Vilas Dhar, president of the Patrick J. McGovern Foundation, who will share more about why it's critical for social entrepreneurs to leverage AI to maximize their impact in this moment.
Hello, and it's a pleasure to be joining you today on behalf of the Patrick J. McGovern Foundation. It's our mission at the Foundation to bridge the frontiers of artificial intelligence, data science, and social impact to create a more equitable, prosperous, and sustainable future. In this context, data science equips us to discover knowledge, insight, and evidence from a world of structured and unstructured information. And at scale, AI and data are among the most powerful tools we have for solving the world's most pressing challenges, like those tackled here at Solve, from the COVID-19 pandemic to climate change to health inequities. Now, if we're to realize this transformative potential, we must create a shared understanding, a shared language, and most important of all, a shared vision on how these tools can be ethically developed and applied for the greater good. With the rapid pace of technological change, it's urgent that we think now about the world that we want to create tomorrow. Even as we work to solve the challenges of technology we face today, we have to build for a future where the benefits of technological advancement are shared by all. And if applied correctly, data science and artificial intelligence have the potential to create economic opportunity, to empower civil society to better advocate for both people and the planet, to strengthen our commitment to democratic institutions, and most importantly, to allow us to connect to our deepest humanity together. And to achieve this future, social entrepreneurs like you are the essential stakeholders. Together, we can build the knowledge needed to leverage these tools responsibly and equitably. I hope that this short course provides you with a brief but potent overview of how you can use artificial intelligence, machine learning, data science to make an impact on the big global challenges that you're working on, and that it points you in the right direction and inspires the curiosity to learn more. Together, we can demonstrate that artificial intelligence and data can be tremendous forces for public good. Thank you for joining us.
Thank you, Vilas, for those inspiring words. We hope that this short course will introduce you to the key concepts surrounding the use of AI for social good, provide you with a chance to delve deeper into these concepts and how they are applied to specific use cases, and present resources for you to learn more about how to integrate AI and machine learning into your own work. To teach the main content of the course, I'd like to introduce Dr. James W. Weiss. Dr. Weiss is a research affiliate and instructor at the MIT Media Lab, where he focuses on the application of artificial intelligence and network science to maximize human efficiency, especially with respect to catalyzing innovation and entrepreneurship. He's also the founder and CEO of Nest.bio Labs, a multi-country incubation and investment firm whose alumni have a collective market capitalization of over $2 billion.
Hi, everyone. I'm very excited to be presenting this quick course on key concepts for AI, artificial intelligence, and machine learning for good. Before I start, I want to thank Geetika Chauhan, who did this incredible job of assembling the slides that I'm about to present to everybody here. So I think the goal of this quick course is really threefold. The first one is to give an understanding or an overview of what artificial intelligence is and what it can do. So this includes things like definitions, example use cases, and limitations on the deployment of artificial intelligence. Second, I think we want to understand how we can identify opportunities for the deployment of artificial intelligence. This includes, what makes a good use case, and then also what are the necessary ingredients for the deployment of these technologies. Finally, we want to discuss a little bit about implementing AI in your own solution. So this includes choosing the right methodology, thinking importantly about the data sets that are needed, and then discussing briefly some concerns that we should always be aware of when we deploy any kind of learning technology to data sets. To introduce you to artificial intelligence broadly, it's important that we have a clear understanding of the different kinds or types of artificial intelligence techniques that exist, and generally speaking, what's possible in the current landscape. So you hear a lot about artificial intelligence, and there's a lot of different definitions and understandings of what exactly that is or what it contains. Generally speaking, to me, a good definition of artificial intelligence is a branch of computer science that is concerned with building intelligent machines or building algorithms that can do tasks autonomously that normally require human-level intelligence. Machine learning can be thought of as a subfield of artificial intelligence that has recently become very popular. And this is largely due to the explosion in the amount of digitized data that's occurred over the past decade or so that has enabled these machine learning technologies to achieve superhuman performance in a wide variety of tasks. The idea behind machine learning is to provide automatic learning abilities based on patterns that are found autonomously in the data. So Arthur Samuel said, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So obviously here he means, you program the program that learns, but you don't actually explicitly program the tasks that the learning contains. Tom Mitchell, who's one of the pioneers of artificial intelligence, said it another way. A computer program is said to learn from an experience, E, with respect to some class of tasks, T, and performance measure P if its performance at task in T as measured by P improves with experience E. And so really all he's saying here in a formal way is that a computer program learns if it gets better as you provide it with more data in doing the thing that you want it to do. So to begin, I'm sure that all of you, unfortunately, are very familiar with spam email. One of the early examples of machine learning was in spam detection. Rather than explicitly creating a spam detection algorithm, we can approximate the ideal such algorithm using a machine learning algorithm that learns patterns about what is likely to be spam or what is less likely to be spam from the data. The benefits of using machine learning in this process is that we can make predictions on new, unseen data that the explicitly coded algorithm may have failed on. So we can learn more complex, more high-dimensional patterns about what really constitutes a spam email without having to beforehand know that and explicitly code that into our program. Since the artificial intelligence and machine learning revolution, there's been a lot of work in deploying these techniques in the social good or social problem context. And so I want to just briefly give you some examples, both in terms of modeling approaches as well as data sets that are available, because both of these are critical in the AI space. The first example in the mental health area is Facebook AI. So they've developed a natural language processing based machine learning pipeline that aids in the identification of whether or not posts should be used or should be flagged as likely to represent suicidal thoughts. This can be used in suicide prevention. Another example is from Professor Chancellor at the University of Minnesota. He used artificial intelligence to aid in opioid use recovery. In terms of data set, the COVID-19 open research data set has been created generally for clinicians who want to explore research in the space and who want to work with AI enthusiasts who want to build models to help solve social COVID-19 related issues. So given these examples, just as a brief introduction to the space, I want to divide artificial intelligence into two distinct classes, which can be useful in understanding the possibilities within the space and how it can be used in your own context. The first class is called supervised learning. This can be compared to the student-teacher kind of relationship, where the algorithm is learning from fully labeled data, and then given unlabeled data in a future test set, uses the patterns it learned from this labeled data to try and identify what the labels should be for this unlabeled data set that it hasn't seen before. And this supervised learning itself can be divided into two categories. Classification, where the algorithm is predicting a class. So an example of this is whether or not somebody will default on a loan given some information provided about them. Or it can be a regression algorithm. Regression algorithm is predicting a real valued number, something like predicting housing prices based on various attributes. So an example of supervised learning in the real world is Pandora, which I think many of you are familiar with. Pandora launched their music genome project where they quantified 450 attributes about each song, things like the tonality of the song, the length of the song, and this was all done by hand. And after manually labeling all these different songs, they were able to recommend new songs that hadn't been seen or listened to previously to customers, and to create these custom playlist radios that we're familiar with. Unsupervised learning is the other class. So we have supervised learning and unsupervised learning. Unsupervised learning is closer to, for example, how a child might learn language without ever being taught, but just by finding structure autonomously from the various input or the speech that it hears during its first year or so. Facebook News does unsupervised learning in this way. So they learn information about your close friends, from your interactions on the website, and then they use this to assemble the news feed that you see when you log into Facebook to try and identify things that are most relevant and most interesting to each user. Interestingly, Facebook is also using unsupervised learning for translations and even computer vision tasks. So you can watch this video separately. Another class of machine learning is reinforcement learning. Reinforcement learning is learning by trial and error, given some clear objective. So by trying various actions and then being rewarded or penalized based on the outcome of those actions, it can learn how to best achieve the task at hand. So this is, for me, very similar to giving or withholding treats while you're teaching a dog a new trick. If you're telling a dog to sit and you reward it when it does, and then you penalize it or you just don't reward it when it doesn't, over time, the dog algorithm is able to learn, what sit means and how to sit. Another example is Google DeepMind's AlphaGo program, which was able to use reinforcement learning to crack Go, which is a much more complex game than the popular game chess. And here's another video that you can watch in your spare time. So given this overview of different classes of machine learning, I want to talk just very briefly about the limitations in the deployment of AI, and especially the limitations that often occur in the deployment in the kind of the social good space, because this often contains unique challenges that may not be present in other areas of AI or machine learning. One often encountered problem is that you may not have enough data. So you need a lot of data to be able to learn these patterns and then generalize these functions that using these patterns are able to predict the things you want to predict. The other potential problem is that your data alone may not be sufficient. Your modeling approach may not be complex enough to capture the task that you're trying to model, or the data that you have may not be sufficient to actually learn the function necessary to capture that task. And this can be solved in a variety of ways, the most simple of which can be finding the missing data to allow you to capture these patterns and add that data in. The third might be that the problem is just too challenging. So realistically, AI is still new in the domain of things like decision making and problem solving. And the current approaches for this task may not be up to the performance standards necessary to deploy it. So, an example of this is applying AI or machine learning to, clinical decision making, especially in high risk outcomes. Okay, with the types of artificial intelligence methodologies out of the way, at least in high level, I want to move into more practical aspects for what we look for when we want to deploy artificial intelligence. So I'll start with a few examples. This is the Facebook suicide prevention example that I highlighted earlier. Facebook AI will look at the text of a post, along with details about the post itself, to predict whether or not this person is at risk for suicide. And if yes, they'll take the necessary actions like sending tips or escalating to local authorities. Their model here uses a score for each word or each letter or each combination of words in posts and comments, which is related to how likely that word is to be related to a suicidal thought. And then their machine learning pipeline takes this along with other attributes of the post, like the time or the date, and input it into a machine learning algorithm called a random forest that predicts whether or not this post is likely to contain suicidal thoughts. Another example is clinical note-taking. Clinical notes include specialized information like patient demographics, conditions, procedures, results, times. And this specialized information can be extracted using natural language processing techniques, which is a branch of artificial intelligence or machine learning, called concept or entity extractors. And then this information can further be aggregated for clinicians to help them make their decisions faster, or to avoid pitfalls, or to be more correct in their decision-making process. And you can imagine this being used, for example, in just designing autocorrect algorithms for clinicians that highlight when there's something that was likely input incorrectly. You can also use methods from artificial intelligence like computer vision to help detect disease like COVID-19. These techniques use convolutional neural networks, the ones that I'm showing you here, to make predictions about whether the patient's imaging results indicates the presence of COVID-19 or the lack thereof. And this, of course, has the potential to make the workflow of radiologists more efficient by helping them focus their time on the most severe cases or the cases that are most at the margin of diagnosis. Professor Tamby here at the MIT Media Lab uses various machine learning methods to prevent and aid in the early diagnosis of tuberculosis. And you can look up these articles in this research in your spare time, but the projects here involve learning how to aid public health workers in designing interventions for tuberculosis patients. It's very interesting. So given all this, how do we know whether artificial intelligence is an appropriate solution for a problem that we're facing? The necessary prerequisite, obviously, is determining technical feasibility. And when assessing feasibility, this is from a McKinsey study, which is linked below, it's important to realize that you have to focus on the activity being the activity under analysis rather than the occupation itself. So as an example of this, there's various predictable activities that could benefit from artificial intelligence, things like data collection, data processing, and predictable physical work in combination with robotics, like moving items in a warehouse. So in your task that you may have at hand, you can start by identifying either A, predictable repetitive work, or B, large data sets that contain complex patterns that could be better analyzed using methods from machine learning to identify patterns or various kind of relationships that you may not be able to find otherwise. And so technical feasibility is a necessary precondition for automation, but it's not a complete predictor that the activity is capable of being automated or that machine learning should be deployed. A second factor that you have to consider is the cost of developing and deploying both the hardware and the software for automation if hardware is required. You also have to consider things like the cost of labor and related supply and demand dynamics. This is a third factor. So if workers are in abundant supply and they're not significantly more expensive than automation, then maybe this is a decisive argument against the deployment of AI or other automation techniques in this scenario. A fourth factor to consider is the benefits beyond labor substitution. So this often includes higher levels of output, better quality, and fewer errors. And this can often outweigh those third factor concerns of reducing labor costs. So just like in our earlier example, we talked about identifying COVID-19 patients based on medical images. If you can use AI to classify the most obvious cases, then you can better allocate the human time on the more needed examples or the more needed cases. There's also regulatory and social acceptance issues, right? So the degree to which AI or machines in general are acceptable in a particular setting has to be weighed. And an example of this is nursing. So in some scenarios, a robot might be able to replace some of the functions of a nurse. But for now, the prospect of this happening in a highly visible way is likely unpalatable for many patients who go into the doctor's office expecting human contact. So the potential for automation or the deployment of artificial intelligence to take hold in a sector or in an occupation really reflects this subtle interplay between these factors and all the different trade-offs among them that are worth considering. So if we think about manufacturing, for example, performing physical activities or operating machinery often can be a predictable environment and represents roughly 1/3 of workers' overall time. And because of this prevalence, something like 59%, and this study is cited below here, of all manufacturing activity could be automated given the technical considerations alone. The overall feasibility, however, has a lot of variance because some of the work is highly skilled and some of the work is more easily replaced than others. There's also a lot of variance between companies or between organizations trying to implement these technologies. Some may have inconsistent or very little use of automation, while others might be quite sophisticated and very interested in automating. The same McKinsey study that I'm talking about here indicates a 69% potential for automation of data processing. This is less than, but still significant, 78% of manufacturing. Data collection is also a likely area for deployment, and you can see there's a variety of other areas where this can be used in the study that I've linked to. Each industry here is categorized based on different work activities like managing others, applying expertise, data processing. The finance and insurance sectors, for example, indicate decent technical feasibility for automation based on data processing for the data processing tasks, whereas the same potential in those tasks is significantly reduced in construction. So as a conclusion of all this, it's important to look at the industry overall based on the work activities so you can see how much time is actually spent on the tasks that you're looking to replace or augment using machine learning or using artificial intelligence. Finally, I think it's important to note, and a very interesting area of research is how artificial intelligence or machine learning can be used to not replace human intelligence, but instead to augment it. This area of augmented intelligence is very interesting and involves learning patterns from complex data that are higher dimensional than the human brain is able to capture, but then either projecting these down to a lower dimension or using these interpretations to aid humans as they make decision-making processes. So this is an example from some of my work here at MIT. We learned a machine learning framework based on academic papers and how they change over time. So we've combined machine learning with network science. And then given this machine learning model, we're able to identify highly talented women entrepreneurs that are located in the Cambridge area, this is a sampling of those, which we were able to provide to a seminar here at MIT that was looking to create a women in entrepreneurship focused speaking series. So once you've assessed the feasibility of applying artificial intelligence in your solution, you need to start to think about, how do I actually implement this? So as a brief recap of the methods that we've talked about, we have supervised learning, which uses labeled data and either predicts a class, which is classification, or a real valued number, which is regression. We have semi-supervised learning, which we didn't talk about, but involves some labeled and some unlabeled data. We have unsupervised learning, which is learning patterns purely from unlabeled data. And then we have reinforcement learning, which is learning how to accomplish some outcome given a sequence of decisions. These inputs and outputs that I'm laying out here are important considerations when you determine which artificial intelligence or, again, machine learning method is applicable and whether or not you can ultimately end up using it. There's also a variety of other methods that you can go into, which I haven't talked about, but are worth reading about. Things like classic rule-based methods, or even more advanced methods like meta-learning. And again, I would encourage you to read about these in your spare time. So in conjunction with determining your modeling capability, you also have, very importantly, data set considerations. Data is the necessary prerequisite for applying machine learning methods because it's what they all are based on. So you have to determine initially whether you have the data required, as we discussed earlier, to actually accomplish the task in question. And then you have to determine not only how to obtain this data, but how to obtain clean data. So that is data that has non-noisy results. And there may be difficulties in this process, right? The data may be inaccessible for various reasons. It may be incomplete. It may be inconsistent. And this process of obtaining the data, cleaning the data, and standardizing it can be quite time intensive and is very important. Because this data collection and cleaning effort can take some time, I generally encourage people to build baseline models using the data that's currently available in conjunction with trying to conduct the full data collection and cleaning task. So you can often obtain open source data sets that are similar in flavor to what you're looking for. And then you can start to build models on this while you're actually in the data collection phase. So this is, for an example, the Mimic CXR is an open source data set that has chest x-rays. And you could use this while you're cleaning up your data from some private hospital. There are also technical and business steps to building out your AI strategy generally, right? So on the technical side, you need to focus a lot of effort on the data, and then you need to move on to the modeling components before ultimately deploying. On the business side, you need to keep ensuring that your AI goals are in line with your corporate strategy. And this often involves getting help from experts in both the technology side and the business side, and then figure out how you're going to measure success using some kind of key performance indicator, and repeat these steps in parallel with the repetitions that are occurring on the technical side to ensure that you're in alignment both on the corporate and technical side. I think this is a useful process to keep in mind when ensuring to ensure that you end up with kind of a robust AI strategy within your organization. Another component that I think is very important when you think about deploying AI in the social good sector, but it's also important generally to keep in mind, is ethical issues that may arise. And these can arise. You don't have to be trying to create an ethical issue for one to arise. They can arise very simply by having biased data. They can arise by creating biased models. And so throughout this entire technical process that I described earlier, you have to be aware of these potential pitfalls. I've highlighted some examples here that you can read about, but they include things like, modeling racial bias in your algorithms when, of course, you don't want to have any there, or over monitoring of certain minorities, data privacy, model inaccuracy, things along those lines. So it's important when you're developing any kind of artificial intelligence solution that you're aware of these issues. And one of the steps here, of course, is to ensure that your data is as bias-free as possible, because if you have biased data, your model is likely to learn that bias and may even be repeating that bias and augmenting it without you being aware of it. So again, I'll emphasize it's important to consider these issues and be aware of them throughout both the corporate side and the technical side as you develop this. So here's just an example of certain issues that are useful to be aware of. There's 7 of them listed here that I think can be useful to iterate through as you're going through the process. This includes things like decision-making liability. Are you accomplishing the level of transparency that you're looking for? Are you increasing or modeling any existing bias? Are the decisions that you're producing consistent with your own values? Are your processes in alignment with data protection and intellectual property ethics and laws? Are you leading to any social dislocation, or could you potentially? And are there cybersecurity concerns? Is there a way that this data could be used maliciously by a malicious actor or the results of your algorithm? So given all of this, here's a kind of a quick guide for responsible implementation of artificial intelligence. First, you want to ensure organizational transparency, typically. Make sure multiple people are accountable for various actions and have a team with clear and different objectives, all of which have a diversity of perspectives. Second, coordinate amongst your stakeholders inside and outside of your organization. Connector people can be very useful here, people that you would trust to help build out public trust in your product, and that can help build inter-organizational trust if that's necessary, which it may be in either data collection or deployment steps. And then expand the notion of your measurable value to have a long-term mindset. Don't push your team too much towards short-term goals, like getting something that works. Not only may that burn your team out, but it also can lead to these biases taking these potential pitfalls could be overlooked in the rush to accomplish short-term goals. So it's important to have this guideline available. So just to quickly recap, we've talked about an overview of what AI can and cannot do for the social good. We've talked about spotting opportunities to apply artificial intelligence in your solution. And we've also talked about implementing artificial intelligence in your solution. So we've gone over the different kinds of artificial intelligence definitions, the types of artificial intelligence that you could be realistically deploying, and a couple specific examples of these to give you a taste of what exactly we mean when we talk about this. We've discussed practical implementations to determine whether the deployment of artificial intelligence or machine learning is actually a good solution for you, and how to do some pre-thinking before you actually get to the implementation and the deployment stage. And then we've talked at the end about the actual implementation of a solution, not only by choosing the right machine learning model and the right artificial intelligence approach, but also how to handle data sets, how to collect your data, ensure that it's clean, and then how to, throughout this entire process, align your technical goals with your corporate goals and keep ethical concerns in mind. So this was a very quick recap to a lot of the key areas to keep in mind when you're thinking about deploying artificial intelligence or machine learning in your own organization. If you've made it this far in the presentation, please feel free to reach out to me directly. jww@mit.edu is my email address, and good luck. Thanks.
It's very clear. AI is a powerful tool with huge potential for social good, and it's equally clear that it's important to wield this powerful tool responsibly. I'd now like to turn to our innovators, who are in fact 2 of our solver teams, who are applying these concepts to their solutions. Julia Kumari Drapkin is founder and CEO of IC Change, a platform that enables communities in the US to share microdata about climate impacts. Abhilasha Purwar is founder and CEO of the India-based startup Blue Sky Analytics, which provides key air quality data and source emissions parameters. Both Julia and Abhi were selected to receive the AI for Humanity Prize supported by the Patrick J. McGovern Foundation. Julia, I'd like to start with you. When you first came to Solve, IC Change was just beginning to think about using AI in your solution. Tell us about some of the indications that suggested to you that IC Change could scale its impact by leveraging AI and machine learning.
Yeah, so IC Change is a climate social media and insights platform, and we help engineers, utilities, and cities track climate impacts, validate models, and better design solutions with crowdsourced data. We use both qualitative and quantitative data to do that, depending on the climate impact. So flooding, heat, drought, air quality. And then we have discrete follow-up questions. So when we started looking to deepen our impact using AI and machine learning, we leaned into NLP, natural language processing, because a lot of IC Change's data posts are open-ended, collecting qualitative data, and the platform is organically shifting with the user's experience. We needed to organize our data in a more scalable way to be able to recognize patterns in our database that could adapt with our users as well. So our first hunch was that natural language processing could help us with a UX issue. That's kind of an efficiency that we saw right away. Our post form, they were getting increasingly complex per topic. And if people miss data inputs, then we're missing opportunities to solve problems. So we wanted to reduce friction in our posting, and that also improves the user experience, both by simplifying the data input and increasing the efficiency of everything. So I think in terms of our process, we recognize that AI and machine learning could help automate organizational processes, making us more efficient and also helping our users enjoy their experience more. So we have a lot of raw content, and it's coming in from across the world globally, and AI helps us better organize our data in terms of the value and creating kind of buckets of content that we could use and reuse. So that was our first step. But then the more we thought about it, we realized that this organization with natural language processing could help us curate the content and the experience for our users. So that's another big part of our value, is tracking weather trends and details. So when users post about flood impacts or heat impacts or drought impacts, we follow up with questions and queries regarding hyperlocal conditions that our clients need to know about too. We evaluate temperature, precipitation trends, whether it's happening earlier in the year or in different ways, and then we analyze those trends manually. So when you realize, okay, now we can pair machine learning of around weather forecasts and environmental data to the new NLP classification, that allowed us to scale our impact even more and automate analysis and predictive modeling. We can now be more responsive to our users' needs and our customers' insights at scale. That's really critical. The scaling for both, having our impact and also our business. So in other words, if you're experiencing climate impacts now, you're more likely to experience them again and perhaps more intensely. So there's predictive modeling value once you start down this path. There's a value chain for both our users, our customers, and our product. And then finally, when we were thinking about how to, increase our value and our impact with regards to humanity, there's a huge educational component with machine learning that now in our platform that it's being brought to our users. When you understand climate trends, that allows you to understand what's happening today and reflect on the fact that this is not our normal. As we adapt, which is humanity's greatest advantage, and also can be a disadvantage when it comes to climate change, we forget where we've come from. We start to normalize things. And so being able to use machine learning and trend analysis to let our users know that where we've come from in terms of our climate impacts and where we're going can allow us to start prioritizing critical decisions that need to be made right away. So that was our process, is really kind of walking through where can we gain efficiency, where can we gain scale, and most importantly, where can we add benefit to the greater humanity with this incredibly powerful tool.
Amazing. Thank you, Julia. That was so helpful. Abhi, when you were selected as a solver, you were kind of on the opposite end of the spectrum. So you and Blue Sky were already using AI. Your capabilities were already quite developed. The prize that you received, the AI for Humanity prize, allowed you to double down on a few key areas. And I'm curious to hear where you decided to invest more resources and grow those AI capabilities, and why you chose those particular business areas.
So let me start by first just thanking MIT Solve and the AI Innovation Prize, because what was it, last year of September when we first came to New York and pitched what we wanted to build. And we had sort of started doing a little bit of AI work, but we were a team of about 6 or 7 people. So just a really tiny startup based out of a garage in India. And we had maybe 2 data scientists, 2 engineers, and that's about it. And now we are a team of about 20 people across India, and we've got folks in New York. We are looking to expand in Netherlands. So, it's been a very sort of, hockey stick journey of growth. I think when we had come to MIT Solve, we had about 70 to 80,000 like hits on our API. And now we have already crossed like 4 million hits of data sets, like people like, coming and checking the number, like what is the air quality wherever they are. Last year when we came, we had hardly like any partner, actually. We had no customer, no partner, just, some product, some data set. And now we have we have partnered with like folks like International Energy Agency, Clean Air Fund, and like various industries, leading mobile companies in India. So most of the investment, I think, for a data company, which Blue Sky Analytics is, always goes into the data capabilities and engineering capabilities. I think we got the AI Innovation Prize in April or something. Time is flying so fast, and we doubled down on our engineering team right after that. So we built out the engineering and the platform team, what we call, or sort of engineering platform infrastructure, to I think about 6 people now, and we are doubling down more on it in this quarter. So we're actively hiring for full stack engineers, tech leads, data scientists, and folks like that. It's all human capital. The best part about AI and technology is that you can create so much value out of just like mathematical and analytical brain that, as a CEO and as a founder, you're always like focusing most on the human capital.
And Abhi, just a follow-up question. Can you say in a couple of lines what Blue Sky is trying to accomplish and how investing in the human capital has really helped you do that?
Yeah, sorry, I totally forgot that. Blue Sky Analytics is a geospatial data intelligence startup, which means that we're trying to take lots of satellite data and analyze and get insights out of it. We focus primarily on environmental and climatic insights. So just like IC Change is effectively crowdsourcing a lot of data, it's like going to people and being like, hey, if you see any climatic event or something, can you enter that? And something that Julia said was that climate change is happening as and when we are speaking. It's not something which is in any near or far future. It's happening right now. So using satellite data, we are able to observe climate change, observe the Earth at a very large scale, and hence the majority, I think I just got an email that we've crossed 20 terabytes of data analysis last month. That is a lot of data that we're analyzing. So we use all sorts of like AI tools from machine learning. We don't do any NLP because we mostly deal with just like quantitative data set, not like qualitative data sets. The main idea is to process all the satellite data that's available out there. I think there are more than 700 Earth observation satellites up in the orbit, and extract insights on air quality, GHG emissions, water quality, extreme heat in various parts of the planet, soil humidity, and provide it to the right kinds of customers or users.
Julia, I'm sure that as you were starting out, you faced a lot of challenges as you were figuring out how to implement AI. Tell us about 1 or 2 of those challenges and what your key learnings were from those.
Sure. And so, I have a wicked smart team. I'm very proud of them. And I have a climate science background, as a climate science reporter. But none of us had experience with AI or machine learning. So I think we did a really great job of educating ourselves on the opportunities and seeing value in our product and what it could do for us. I think our biggest challenge was operationalizing it because we wanted to be, and always have been, wicked ambitious. We wanted our product to be unique and impressive, and we're building that, and dreaming big is critical. But getting to our vision meant we needed to start with basics. We needed to narrow to be more focused and to get more focused feedback. That was really critical for us. Breaking it down into realistic steps and being mindful of our team's capacity. So when we got this amazing prize from the Govern and from MIT Solve, we didn't have the staff right away to be able to execute at the time. So the funding came in, we had to wait until we had enough resources to update our code base and set up our Python server and hire our first data scientist. And all of that happened. But in the interim, we were able to do tests and prototype so that when we were able to execute, we were ready. So I think that was really critical for us. It's just, dreaming big is great, but being very, very focused on the implementation and walking it through step by step is critical.
Yeah, that makes a lot of sense. On that same line of questioning around implementation, so Abhi, as you were using AI to scale further, were there any sort of ethical issues that you faced, or how did you think about balancing responsible implementation with trying to scale as rapidly as possible?
God, that's a very difficult question. One of the good things about like the data sets that we operate is it's actually pretty much non-personal data set. We don't take any consumer data set or any user data set. It's all, carbon dioxide and nitrogen dioxide and water. So that sort of, I think, helps our life because it's much more objective than subjective. And within the data scheme of things, I think the ethical sort of burden on us is much lower as compared to, if you're working with more people's data. But nonetheless, we were recently watching this documentary. It's The Social Network, which is by a lot of like ex-Facebook, ex-Instagram stuff. And as we are thinking about people using the APIs or, people using our data sets and various kinds of applications, there's a burden that almost every entrepreneur or every engineer starts to feel, which is, we have seen the journey of what Instagram and Facebook was designed for and originally built for and what it is yielding today. So I think in our case, it's just being much more conscious about the fact that tomorrow when these data sets are available, really, in the fullest of extent to all of the people across the planet, and they could just swipe their card and pay the bill and get that, there might be a huge variety of applications that could come out of it. And some of those applications might not be entirely ethical. And as the founder and as engineers who are building this, the responsibility of thinking about those use cases and taking the right kind of action to minimize those use cases in future, I think comes on us. Something which has changed drastically for us was that we were, as young entrepreneurs, as young founders, we were like, oh, you know what, we're going to build this up and then sell it off and then, become rich. But, as we have seen the journey of other big tech companies or big tech products, which have gone through that journey of building and selling, but then not having the ethical control over their own product. In this case, like both WhatsApp and Instagram, I think that me and my co-founder both have really focused. Okay, we're building Blue Sky with all our heart out, but let's make sure that we are able to implement the kind of ethics that we stand for 5, 7, 10, 15 years down in the future as well.
Can you give an example of how you're doing that?
As of now, I think not so much because right now we are not even we're still building it out. But it's going to be more like tomorrow if we get a customer who wants to buy the data and we know for sure that the use case they will, implement it would not be the most ethical use case, then I think, being able to have this decision that we're not going to sell it to you, that's going to be the more, I think a lot of, it's just more of cognizance about the fact that our data could eventually not have the best use cases. And it's hit us in the past 2-3 months only. It's not been a very long phenomena. It's if I'm giving information about drought to people, it could be used for hoarding and rocketing up prices and not always for the best kinds of implementations. Yeah.
Yeah. Julia, I feel like you might have had something to say to this question as well.
Well,
any thoughts?
Lots of thoughts. There's no such thing as objective data, potentially, in the sense that all data is powerful, subjective, and can be used for good or could be used for not good. And I think that it's really critical for all of us to have a data education about what is powerful data. I think that we appreciate that what we're doing is so rooted in our value system that we are using our values to navigate difficult situations. So we spent about 3 months this year as a team kind of narrowing down to 5 words that will help us navigate challenging decisions. And we've written it on our website, we have it in our mission statement, and I think that we're using that as our compass to always, because when you're innovative, when you're trying to create paradigm shift, there are situations that you can't anticipate. So as long as we are rooted in our mission and our values, we feel more confident to reach forward. But yeah, climate data is sensitive. Flood data can change insurance rates. Drought data can be used by primary commodity traders to make a lot more money at a lot of people's pain and expense. And particularly when it comes to climate change, I think one of the things that we're trying to teach everyone, whether it's our clients or our users, because we're a two double-sided market, is that we're all in it together, and we all benefit when we solve the problem. So that's really kind of how we've handled it. Yeah.
Great, thank you. So we have just a couple of minutes left. That was so helpful to me to hear all those answers, and I want to close the panel with some advice from each of you for all of the social entrepreneurs that are on this short course today. So for those who are either just starting out using AI or for those who are already using it to scale, what advice would you give? I'm going to give you 45 seconds to answer. So Abhi, let's start with you.
Quick answer for that. I would advise all the social entrepreneurs to actually really think a lot on the first principle of whether you're causing a final impact or not, or you think you will lead to climate action, you think your solution will have some benefits, but it's much smaller or much tertiary, or it's not like solving the problem at base. If I have to give an example, climate change is a big cancer. It's like a really, really big and complex problem with many layers. So go deeper instead of just the surface level and building a Band-Aid, which is that a lot of social or a lot of environmental startups are coming with more Band-Aid solutions. And when you find a first principle-based solution, you have all the technology on the planet available, from like AI and cloud computing and great engineering prowess that we've made in the last 30, 40 years, that you'll be able to apply these technologies to solve your problem. But going first at just what the solution is going to be really important.
Great. Julia?
Sure. So if I was a solver, I'd start out by focusing on where your company or your service has immediate friction when it comes to AI. And then, all of you amazing solvers have great ideas on how to solve local problems. And AI allows you to be more efficient, to reduce that friction. So kind of figure out what is causing you friction now. And then next I'd zero in on what is not scalable about your approach. And if AI can bring meaningful value to you. And then lastly, and most importantly, of course, is thinking big about how we use AI powerfully to transform our experiences for good and truly embrace this power. That's all in the ideation. In terms of implementation, I'd focus on structuring your approach and being mindful of where you are in your product roadmap. Which part of AI makes the most sense? Do you want to apply it to language or visuals? Figuring out groups or similarities in your data, classifications or categories, but be mindful of your capacity, where you can learn quickly and implement at scale. So I guess aim for the stars, land on the moon, and then you're that much closer to Mars. And we're, and really, we're grateful to the McGovern Foundation and MIT Solve for helping us build our ship. And we welcome anyone from the MIT Solve community to join us on it. Yeah.
Wonderful. Well, thank you both so much for your insights, for your advice, for all of the entrepreneurs out there, and for really bringing to life some of the key learnings that we got from Dr. Weiss in his lecture. Have a great rest of the day. We're nearly at the end of our time together. I'd like to thank our panelists, Julia and Abhi, and our lecturer, Dr. James Weiss, for sharing their wisdom today. If you're interested in learning more about using AI to expand your impact, I invite you to check out the AI-related resources, including free courses and toolkits on Solve's website. And be sure to subscribe to our newsletter and check our website regularly for announcements about upcoming and open challenges. Finally, I'd like to turn it over to Vilas Dhar, President of the Patrick J. McGovern Foundation, for some closing remarks.
Every day, the average person interacts with products, services, and companies that are using artificial intelligence on an accelerating basis. These interactions happen in ways that aren't immediately obvious, but we're seeing how AI and data science are guiding policy, scientific inquiry, the delivery of services, and even self-discovery. This opportunity to impact every part of our daily lives marks why it's so absolutely vital that the tools and products and services we develop with AI be used responsibly and to the benefit of the social good. Our vision at the Patrick J. McGovern Foundation is of that brighter future in which technology amplifies the very best of humanity. Our creativity, our ingenuity, and our curiosity, and most importantly, our kindness and our generosity. But it's up to innovators like you across the world to leverage these tools responsibly, to employ them to expand your impact, to grow the scale of what's possible, to prioritize those most in need, and to build a better, more inclusive future in a digital era. Speaking to you today and in partnership with MIT Solve, I feel more hopeful about that future than ever. Thank you all so much.